Hello everybody and welcome to Pisa Presents. Today we're going to be looking at amphibole minerals, a very varied group of minerals. There's over 100 in the group potentially, all with a couple of small things in common, but still giving you quite a lot of variety. So what do they have in common? First of all, minerals of the amphibole supergroup center around chains of silica tetrahedra. They're most common in metamorphic and igneous rocks, and their name is a reference to their highly varied nature. So ampha is the same root from amba, or say like where we get ambidextrous from. It means both. It's reference to basically say two or multiple forms of these chains. Now, there's potentially more than 100 species. That's something that's up to debate. And each one of them has a splintery fracture and perfect cleavage, or basically the way that the mineral breaks, in two directions. So here is a paired version of these tetrahedra that are chained together. Now, those big white marshmallows right there, those are the oxygen. You see, you can kind of count four of them together, three on the bottom and then one on the top. And then each time they're sort of interconnected to another group. But where's the silica? Well, he's hiding right in there, all the way in the middle. But there's obviously a lot more going on in here. I mean, you can't just be chains of silica tetrahedra. There are actually other atoms bonded to this branching off from the sides. So, well, what other atoms do we have? Turns out there's quite a lot. So that word salad right there is actually the overall master formula for the amphibole supergroup. Basically A, B, C, and T, where you see them, they can substitute for other things. So T can substitute for the silicon, aluminum, titanium. B can be anything from say like zinc, calcium, iron with a 2 plus charge. C can be iron with a 3 plus charge. So not only can you substitute different elements, but you can even substitute elements with different charges as well. Now all this together forms the silica tetrahedra at its core, with these other elements in various combinations branching off of it. Now that internal structure, that core tetrahedra, and then the branching is what gives them such a diversity. Because really, if you think about it, just something chained all together, well, think of a chain. So now, if a chain is pretty taut, it's fairly tough, right? But still, if you were to hold a chain in your hands and move your hands close together, it would still be pretty flexible. And that flexibility is, again, what allows for a lot of the diversity in amphiboles. Their chemical structure is just an absolute master of engineering. Now, how that chemical substitution can occur is something that can get extremely complex and is something that people argue about quite a lot. So instead of going into that toxic mess, why don't we gaze upon this adorable little kitten, and if you should so feel motivated to, I may kindly direct you to the following two sites down there, please. Amphiboles are often confused with another mineral group called pyroxenes, right there. So what are the differences? Amphiboles are hydrous and have hydroxyl groups. Pyroxenes do not, and as a result are more heat stable. So basically, if you heat something that theoretically can combine chemically into water fairly easily, then, well, you're not going to be very heat stable. Now, pyroxenes also lack an A portion in their formula, or really any such place for potassium at all. Amphiboles overall have a hardness between 5 and 6. Their specific gravity ranges from 2.9 to 3.6. And unsurprisingly enough, for something that has a pretty big variety in sort of chemical composition, it has a whole lot of different colors, with the colors linked to their chemistry. So let's look into some of the substitutions and really what can occur. So iron-free varieties of tremolite containing manganese are purple, but if it has iron in it, so if it is not iron-free, it's green. So green or purple, all depending on whether or not you have iron just for tremolite. Now, this is cummingtonite right there. The cummingtonite to the grunerite series, a series is basically a group of linked minerals that are chemically linked, that is. They're yellow to brown. But if just cummingtonite itself has a lot of magnesium in it, it is a very, very pale yellow-brown. Glaucophane and rebecite are often blue. Here is a specimen of glaucophane right there. Now, this particular series, tremolite, ferroactinolite, are all white, dark green, depending on the iron. So the iron determines the darkness of the color within it. Now here is another specimen that is right there. And what's hornblende? You may or may not have heard of the mineral hornblende. Well, it's actually not a mineral. It's more a group name for very dark green to black amphiboles. Now, we're going to look into some famous amphibole minerals right now, but that one right there, all those pictures, that's actually the same type of mineral, the same group. Now, what group do you think that is? If you had to think right now, what would you say that was? Well, if you said it was the dirty dozen, well, not really dozen, more like a lot fewer, 6, but still asbestos, then you're right. So let's just start right off the bat with the most notorious amphibole, the asbestos group. 6 of them, roughly. Can be a little bit more, can be a little bit less, depending on who you ask. Their name translates to unquenchable and refers to their well-established fireproofing ability. People have been using asbestos in various forms as some sort of fire prevention or fireproofing material for a very, very long time, millennia. But like many amphiboles, remember that fracture earlier? They fracture into small pieces, which is why certain forms of asbestos are such a health hazard, because if you work with them, then it fractures, can get into your lungs, and then, God forbid, results in a variety of extremely nasty health conditions that, trust me, you do not want to have. So the actinolite tremolite series, anthophyllite, coming to nitrogranarite series, and rebecite are all asbestos minerals. Amosite, or brown asbestos, or other names for the coming to nitrogranarite series because, well, I guess brown asbestos is a bit easier to pronounce than that, but still. And rebecite is also called blue asbestos. And there it is, right there. Now, actinolite is another mineral in this group, so here's some of this. Lovely, lovely green color, as you can see. Here is another amphibole mineral, anthophyllite. Here is glaucophane with magnetite, the dark black, along with molybdenite, and those little flecks in it are pyrite. Grunarite is another amphibole. Pargasite is also another one, as well as richterite and tremolite. And if you're interested, you can follow up on some of our other videos like this one right here. So thank you very much, folks. Thanks for attending, and hopefully we'll see you soon. Bye now.